In this tutorial, we will create and test an RC integrator circuit. Let's first place the resistor component of the integrator. Move the cursor over the resistor icon on the component toolbar and click the left button of the mouse. Now the resistor symbol is attached to the cursor and may be moved anywhere on the screen simply by moving the mouse. By clicking the left button again, we place the resistor. Now the resistor is placed with a default value of 1K. The default value can easily be changed by double-clicking the resistor. The Properties window will appear. In the resistance line, we change the value to 2K. By pressing OK, we confirm the change. Now let's add the capacitor to the circuit. Using the same technique, we move the cursor over the capacitor icon. By clicking the icon, the capacitor symbol is attached to the cursor. This time, we first want to rotate the symbol by 90 degrees. We move the cursor over the Rotate Right icon, click on it, and the resistor symbol is rotated by 90 degrees. Now we move the symbol to the desired location. Note that the resistor may also be rotated after placement. Next, we will add a generator to the circuit to test the integrator. We click the generator icon and move it to the desired place. To see the default waveform, we double-click the generator. The default is a unit step. To see other available waveforms, click on the signal line. A small button with 3 dots will appear. Click on this button to see other available waveforms. Moving the cursor over the icons, the name of each waveform appears: pulse, unit step, sine, cosine, square wave, triangular wave, general waveform, piecewise linear, and user-defined waveform. Let's select the pulse waveform. By clicking the icon, the property dialog of the pulse wave appears. We change the length of the pulse to 2 milliseconds. By pressing OK, we confirm this change. The voltage generator dialog then appears. We press OK here as well to finalize the generator settings. Now let's connect the components of the circuit. We move the cursor over the upper terminal of the generator until the cursor changes into a pen. We click and release the left mouse button. Now connecting wires may be drawn simply by moving the mouse. Note that the left mouse button should not be held down while drawing the wires. While drawing a wire, we may delete previous sections by moving backwards along the same track. To complete the process, we move the mouse over the left terminal of the resistor until the pen changes back to an arrow. Click the left mouse button to finalize this wire. Let's draw 2 more wires with the same technique. Again, we move the cursor over a terminal to change it into a pen. We click the left mouse button and release, then draw the wire. By clicking the left mouse button again, we finalize the wire. Finally, let's draw the wire at the bottom of the circuit. Now we still need to add a ground to the circuit. As well as a voltage pin from the meters component toolbar. To add the voltage pin, we click the meters tab and then the first voltage pin icon. Move the voltage pin icon to the upper pin of the capacitor. The circuit is now complete. Let's save it together with all the parameters set so far. We select Save As from the File menu, enter the name of the file, and click Save. Now let's conduct a transient analysis to test our circuit. From the Analysis menu, we select Transient. The Transient dialog box will appear. To set the endpoint of the analysis, we change the end display parameter to 10 milliseconds and press OK. The result of the transient analysis will appear in the diagram window. Note that all analysis results are stored in the diagram window, which may be viewed at any time by selecting Diagram Window from the Tools menu. Now let's close the diagram window and conduct an AC analysis of the circuit. We click Analysis on the main menu and move the cursor over AC Analysis. A submenu with AC Analysis options will appear. Select AC Transfer Characteristic. The AC Transfer Characteristic dialog box will appear. Let's change the default end frequency to 10K. And add amplitude, phase, and Nyquist to the requested diagrams by clicking the checkboxes. These diagrams will now appear in addition to the default amplitude and phase, or Bode diagram. We will receive 4 separate diagrams after the analysis. We press OK to carry out the analysis. The diagram window appears, showing the amplitude of the transfer function, the gain of the circuit in decibels. We can view the phase, Nyquist, and complete Bode diagram by clicking the tabs at the bottom of the diagram window. We can also see the result of the previous transient analysis by clicking the TR Result tab. From the File menu of the diagram window, we can save and print the diagrams, or export them to other programs in various formats. The diagram window offers numerous other options, including adding labels, legends, cursors, and more. We will discuss these features in other tutorials. Finally, let's save the circuit again, together with all the parameters, including analysis parameters set during the transient and AC analyses. We simply press the Save button on the toolbar or select Save from the File menu. This concludes the RC integrator circuit tutorial.